So, you have 100 meters of fencing and you need to enclose a rectangular area. What dimension should the rectangle have to maximize the enclosed area? You must use all the fencing. Okay, so this is an optimization problem. You need to know how to analyze functions using derivatives. But usually when you have an optimization problem, I'd say start with a picture. That's not a rectangle. Start with a picture, especially if it's geometry. Okay, that's a bad rectangle, but it's a rectangle. X, Y. Okay, so now we need to write down our constraint. The constraint is something that we must follow. So it says that I must use all the fencing. So that's our constraint. So this is X, this is Y. So if I must use all the fencing, that means our perimeter has to equal 100, right? Equals 100. I'm just going to simplify this down to make it a little bit easier. X plus Y equals 50. Now to the optimization part, optimize. It says we have to maximize the enclosed area. Okay, so an area of a rectangle is just xy, right? Length times width. Now, I can't derive this unless I can take, or sorry, I can't take the derivative of this unless I actually put this into one single variable. So that's what I'm going to do. I'm going to take y equals 50 minus x. I'm just going to put that right in there. So now I get a equals x 50 minus x. Okay, I could take the derivative right now and use the product rule, but I feel like that's going to take a lot longer, so I'm just going to expand it. Boom. And now I can take a prime, or the derivative of a. I get 50 minus 2x. Okay, now, what I need to do next is find the critical points, right? Because the critical points is going to give me my value, or potential for extrema, or the minimum or maximum. Now, let me just write this over here. Critical points. How do I find critical points, if you remember? Well, I just set the derivative that we just found either to 0 or to undefined. But since 50 minus 2x is a line, it won't ever be undefined. So you just set it to 0. 2x equals negative 50. X equals 25. Since this is the only critical point, like we know, it's a maximum. So our x value, so our x length is 25 meters. Make sure you write meters. Now I can just put this back into our x plus y. So 25 plus y equals 50. Y equals 25. And we have our dimensions. So we did all this math. The only problem is we haven't written down the answer yet. So our answer is going to be, it says what dimensions? It's going to be 25 meters by 25 meters. So our answer is, it should be x is 25, y is 25, and that's going to give us the biggest area. So the biggest area is actually going to be 625 meters squared. But they don't ask for that. You just ask for the dimensions, and boom, we're done.